Alrighty, good afternoon everybody. This is a live tropical update looking at a general view of the whole in the Atlantic Basin. I'm also going to do a quick recap of Hurricane Hanna. Here is a long-term radar loop from Radar Omega showing that storm coming into deep South Texas there with 90-mile-an-hour sustained winds. And notice how that eye is not a perfect, it is not showing perfect symmetry. It's a little bit of an ellipse as it comes in. Here is the high-resolution radar imagery as that storm made landfall near Port Mansfield in the barrier island there of Padre Island, they're called. There's North Padre and South Padre. But notice how there's little asymmetries within that eye. There were mesovortices within the southern eye wall, and the eye overall itself was elliptical shaped. And that's really what we're trying to capture with the subsonic sensor. Those asymmetries within that vortex as it's coming ashore will show a repeatable signal in the spectral data that is measured by the subsonic sensor, and I'm hoping to have that ready for the next tropical cyclone. It looks like it's not going to be quite ready in time for Isaias as it's coming in, but I am hoping that the next wave that's coming off the African coastline, that one could be an interceptor that we are using the subsonic sensor for. Either way though, if Isaias becomes a significant tropical cyclone, we're definitely going to intercept it. We've already been discussing plans, logistical plans for intercepting. I'm not sure if I'm going to be driving the Dominator 4 all the way across the country for this one or not, but definitely is potentially a system that we're watching very closely. And it looks to me like the ball of convection on the southern end of that large tropical wave is really going to be what we need to keep an eye on. I think that even could give a potential tropical cyclone the chance of passing just to the south of the Greater Antilles. But anytime you have a track of a tropical cyclone directly over the Greater Antilles like that, there's a good chance that it's not going to make it across. However, different than Tropical Cyclone Gonzalo, PTC9 is a much larger tropical wave. There's cyclonic vorticity over a very large area from the north to the south. So it's very easy that a lobe of vorticity could split off of that wave to the south of the Greater Antilles, maybe even to the north. If it happens to the north of it, that tropical cyclone is likely going to recurve around the western edge of that Bermuda High. But if it does go south of the Greater Antilles, even right over it, and somehow can enter the Gulf of Mexico, then I think that there's a chance of rapid intensification and a much more formidable storm. But as I'm going to show you in the hurricane models and some additional global models, there's a lot of uncertainty right now with the PTC9, and that's because it's such a large tropical wave and it has yet to form a closed center, or at that point it'll be named a tropical depression, but it's still an open wave of cyclonic vorticity migrating across the Atlantic. And it's pretty early in the season to get a Cape Verde system that will intensify off the coast of Africa, go all the way across the Atlantic, and also threaten the United States. Usually that's more second half of August and into September. But the fact that we're already getting these systems moving all the way across the Atlantic and already starting to threaten the United States, that's probably a sign of a very active season ahead. But this is the loop from Hanna, and I wanted to recap quickly Hurricane Hanna and look at some of this imagery as it came ashore. And another thing that's very striking about this system is how quickly it was intensifying on approach to South Texas. And I do think that if this had another 12 to 24 hours over the open Gulf of Mexico, which is quite warm, we likely would have been dealing with a Category 3 or 4 storm, similar to what Hurricane Harvey did as it was on approach to Rockport a couple years ago when we intercepted that. This one was eerily similar to Harvey on approach. It was stalling out after it made landfall. Eventually it did migrate into northern Mexico and caused some major flooding problems, deep South Texas into northern Mexico. But if this had another 12 to 24 hours over the open Gulf, it would have been a much different story and a much more substantial of an event. Here are some more radar loops, including that radar track overlaid there from Radar Omega. Thanks to Don Murray for providing me this imagery, satellite imagery on the left in 3D, so you can see those high cloud tops organizing, that big feeder band. That was just as that inner core was really getting organized on approach to the South Texas coastline. And it certainly is true that if this system had another 12 to 24 hours, it would have been a strong one. But if we had the subsonic sensor on the ground deployed inside that eye, we likely would have seen a signal from those mesovortices that were rotating around, causing those winds to gust a little bit stronger at times. I saw many of those mesovortices organizing in the southern eye wall. I experienced a couple of them firsthand, as well as I was driving off to the north on Highway 77 in the northern side of the eye. There was a huge surge, probably a triple-digit wind gust that came from east to west, and I think it was one of those mesovortices that was spinning around inside. Here is an earlier loop of satellite that shows a supercell storm that was propagating from north to south in the west side of a broad circulation. And that little heat tower or heat vort right there was releasing a ton of latent heat. And as that got entrained closer to the center of that, this was a tropical depression at that time, as that got a little bit closer to the center, it accelerated that latent heat release, accelerated the positive feedbacks. There was a rapid surface pressure fall, and the more latent heat release that was released throughout that column, the more rapid the surface pressure fall. And the more rapid the surface pressure fall, the more convergence at the low levels to support that increased thunderstorm activity. And then that leads to even more latent heat release. And it's those positive feedbacks that lead to the rapid intensification of tropical cyclones and their organization altogether here across the tropics in a barotropic environment, as we call it. That's an environment that has minimal to no wind shear, minimal temperature gradients. A baroclinic environment, on the other hand, is one that is comprised of temperature gradients. That has increasing wind with height. You get a jet stream aloft. That's due to a relationship called the thermal wind relationship. We'll go over all of that during these live streams in the off season, including basic force balance as well. We'll break down some basic calculus additionally. But tropical meteorology is a little bit more like playing Plinko. It evolves just a little bit more slowly, and in a barotropic environment, just a completely different approach to the meteorology down here. But there are some overlaps. You do get supercell storms embedded within these complexes of storms. You often get supercell structures even embedded within the eye of these tropical storms. And basically, a hurricane is just a giant MCS, or mesoscale convective system, comprised of meteorology and extreme weather on a variety of different scales. And now I wanted to show you a quick video. This is from my Sony camera, and this should show you what the sound was like inside that hurricane. And then I'm going to pivot into our subsonic project a bit. But this sound that you can hear through the during Hurricane Hanna through the microphone of my Sony camcorder, you can almost hear waves in there too as the flow is increasing or decreasing. But our subsonic sensor is interested in basically sound that you can't hear but is below what is audible to the human ear. That's where there's a lot of interesting meteorology, and you can use that data to discriminate between tornado-producing storms and non-tornado-producing storms, or the presence of mesovortices within a hurricane, or the presence of a damaging storm surge. Really, who knows what these sensors will be capable of measuring. Ultimately, though, we do want to get 3 or 4 of them so we can triangulate where those frequencies are being emitted. That's certainly going to be key. But the first step is just getting that sensor out in the field, inside an eye, and measuring data. But this is video I just posted yesterday from my Sony camcorder that really shows some of the sounds that you hear inside of a hurricane, even a Category 1 hurricane. And a lot of that sound is from the wind going up and over power lines or through the trees or around the building structures, basically interacting with the friction of the earth. And let me hear it here a little bit. It should start over again. But there you can see that boathouse and the RV park that sustained pretty substantial damage out here. Most of the other structures, the damage was quite minor, as you'd expect from a Category 1 hurricane, with those maximum sustained winds at about 90 miles an hour. But still definitely formidable, and there was a pretty substantial storm surge of about 5 to 6 feet. A lot of that also impacted North Padre Island, a little bit closer to Corpus Christi, where there was a lot of onshore flow. But here you can hear some of those sounds. I'll just let this play for a few minutes here. Another part of our mission that we'd like to do is to launch balloons and drones inside the eye and get a vertical sounding as well. And here is my intercept of the eye. There you can see. I was in the southern portion of the eye. This is in Port Mansfield, and this again is radar omega imagery there. Looks like a perfectly symmetric eye at least in terms of the greater reflectivity. But then you look inside the lower reflectivities within the eye and look at all those eddies inside of it. Pull up some of this imagery here. But I was initially waiting in Port Mansfield for a really long time. We were getting hammered by the southwestern portion of the eye wall there for a long time, and I was just waiting for that eye to finally wobble ashore. Eventually it did, but the eye wall definitely stalled out over Port Mansfield. That caused a lot of the damage there, as those Cat 1 winds were lasting quite a bit longer in Port Mansfield. But this is my location, entering the southern portion of the eye and measuring a minimum pressure down to about 977 millibars using the embedded pressure sensor inside my iPhone as accessed by the Radar Omega app. And right in the middle here, there were some recorded pressures, 972, 973 millibars, actually as estimated by Hurricane Hanna aircraft. They were flying missions as the storm was coming ashore. But I actually had a couple of different eye intercepts, showing you the next one here. And this is when I experienced one of those mesovortices coming from the east to the west, but a very strong wind gust, probably a triple-digit wind gust, impacted my location here as I was heading to the north on Highway 77. And I believe that's because of asymmetries within this eye wall. There's mesovortices or tornado-like features embedded within this throughout this structure. They're more easily documented in the stronger hurricanes, but you could certainly see them in Hurricane Hanna as they were coming ashore. And it's these asymmetries within the eye wall that we're really interested in sampling with a subsonic sensor. We're going to have to deploy that inside the eye because it does require a lack of rainfall. It requires relatively calm conditions to be able to resolve those subsonic frequencies. So that's why we really want to deploy that feature inside the eye or in the moat on the outside around the eye wall. There's also an area of calm that often forms on the outside of the inner eye wall. That's from sinking motion on the outer periphery of that deeper convection that comprises the eye wall. That is also a possible location for us to deploy the subsonic sensor. But we're really interested in measuring those asymmetries inside the eye, those mesovortices or tornado-like vortices that are embedded within that circulation. And I do believe I was impacted by one of those right there directly in the north side of the eye as I was heading north to try to intercept those tornado warnings in the outer bands. And I did get in the path of one of those tornado warnings just to the south of George West, Texas. And these are basically supercell storms that will form in the outer periphery. A couple of them look like they did produce, but they were quick, brief tornadoes. Here is a look at the radar imagery as I was waiting for those little supercells that were forming in the outer bands there to arrive. They were moving at about 45 miles an hour, and I was in an active tornado warning. It does look like there was a pretty tight couplet with one of those as well. But that's one thing, when you're chasing a hurricane or a tropical cyclone, you're often also chasing tornadoes out there in the outer bands, and sometimes these tropical storms will come inland and become prolific tornado producers like Hurricane Ivan back in the day, back in 2004. That was one of the most prolific tornado-producing tropical cyclones after it made landfall across the eastern U.S. and recorded history. Well over 100 tornadoes were caused by Hurricane Ivan after it came ashore. So here's some of the subsonic data that Mark has been collecting, and this was deployed in the path of a tornado-warned storm that was coming into Calgary. And notice the cyclic nature of that. He was only able to deploy for a couple minutes before that large hail arrived. But this is time on the lower axis in minutes. This is out over about a 2-minute period that these were measured. And after some spectral analysis, you can really see where these spectral lines were hammered. And they were in a repeatable frequency too. So this is possible that this was the clear slot punching into the mesocyclone. It's possible that it's due to asymmetries in the mesocyclone as well. This was a tornado-warned storm. So whenever you get tornado potential with a mesocyclone, you have a clear slot that's punching into it. That, just by definition, leads to an asymmetric mesocyclone rotation. And if you have a little lobe that's on the outside of that, a little nodule, every time it passes by, that's going to have a subsonic frequency that we're going to be able to interpret. And you can see a lot of background noise here as well. That's probably gravity waves caused by surges in the rear flank downdraft interacting with the topography. But really it's the signal here that you want to keep your eye on. These right here are what we're going to be looking at, and it's going to take a lot of deployments to really figure out exactly what features are causing these. But we're going to be deploying these in hurricanes, next to tornadoes, next to large hail cores, and really hopefully we can ascertain what's going on inside the storm by deploying these sensors out in front of them, around them, or inside the eye as well. And that's all been made possible by you guys, by our Facebook supporter group, the Team Dominator group, the Facebook stars. All of that is supporting storm chasing, live streaming, and our Team Dominator science. And we've got a bunch of sensors ready to go for next spring for when the COVID pandemic allows us to travel south out of Canada. We're going to have the Dominator 3 out in the field, launching rockets into tornadoes, trackable sensors. But right now, we've used this opportunity to bolster the Subsonic project, also the hail impact sensor, which can be used to measure rainfall rate as well. So now let's get back to what's going on right now inside the Atlantic. And there you can see the large tropical wave right at the center of the screen. That's a Potential Tropical Cyclone 9. And we've got a Bermuda high that is spinning up here just to the east of Bermuda. That's the main steering mechanism. The jet stream is pretty far north into the US, but you could generally see the curvature. So if the system were to go nearer to the north of the Greater Antilles, it would have a tendency to want to recurve and miss the US and curve around the western periphery of that Bermuda high. As a general rule, a stronger tropical cyclone tends to have a more poleward track, and a weaker tropical cyclone is more equatorward. This is just a tropical wave right now. So this is an open wave of cyclonic vorticity. It's a large wave stretching all the way well north of the Lesser Antilles to down almost just north of the South American coastline. And right now there's so much uncertainty with the models because it doesn't have a closed center. It's not a tropical depression yet. And I'm going to show you the latest hurricane reconnaissance data as well and show you why it hasn't been upgraded to a tropical depression. But a wave of this size, of this north to south expanse, has a greater likelihood of surviving passing over the mountainous terrain of the Greater Antilles, the mountainous terrain of Puerto Rico as well, but especially Haiti and the Dominican Republic, because when you have a large swath of cyclonic vorticity here as an open wave, it is possible that something on the southern periphery, burst of convection out there, could encourage the formation of a closed center further south amongst that wave. It's also possible that that could happen on the north side. But what I'm seeing, just eyeballing here, is it looks like there's a lot more convection on the southern side of this open wave. And that has a greater potential of developing a closed center as it approaches the Greater Antilles. But then we'll have to see if that can survive Cuba, Haiti, and the Dominican Republic. But if it does take a further south track, which could be encouraged, then I could see this system eventually entering into the Gulf of Mexico. So this is not just an eastern U.S. or southeast or eastern coastline of Florida type of a concern, but the Gulf of Mexico is also in play, given the model uncertainty and the large north to south expanse of this open wave. Here's a loop a little bit closer showing this open wave, and you can almost see, just looking at this feature, the lack of a closed rotation. And for this to be upgraded to a tropical depression, it does have to have the closed winds all the way around. Right now this is just an open easterly wave, which means that it has cyclonic vorticity, but those winds are not closing around a consolidated center just yet. And that was confirmed by Hurricane Hanna aircraft. But you can certainly see there's no shortage of convection on the southern edge of this wave. Quite a bit of explosive convection down there, and it is possible that the latent heat release from these blobs of convection could be sufficient enough, and those positive feedbacks will take over to develop a tropical depression down here to the southeast of the Greater Antilles, which would increase the likelihood of a Gulf of Mexico storm developing as well. So now I'm going to show you the latest hurricane model data, and this is from the Tropical Tidbits website, a great website run by Levi Cohen. And these are the new 12Z hurricane model tracks. And again, you have to take these with a grain of salt because where these models are initialized, that's not even necessarily the center right now because it doesn't have a center, and that center could definitely change dramatically between now and tomorrow morning or when the new suite of these hurricane models arrive. So it's very possible that this center is actually a little bit further south, maybe even southwest than that, closer to those convective blobs. Right now there's not a center, it's just an open wave, just an open easterly wave. It'd be the wrong way. So it's just an open wave right now. And you really need, this is a tropical wave in the easterlies, moving from east to west. And when it's open like this, there's nothing to close that rotation. And you really need a westerly or a northwesterly wind to develop a closed rotation somewhere along this wave. But right now, the wave is very large in the north-south. So it's possible that a consolidated center could develop in the north side of that tropical wave. It's possible that it could develop in the south side of it. Right now, based on satellite interpretation and eyeballing, it looks like that center would be more likely to form on the southern periphery of that wave, which then it would take a further south track, even to the south of the Greater Antilles, to the south of Cuba, eventually entering the Gulf of Mexico. And you may notice just over the last day or two, these forecast tracks have been shifting from east to west. Before, it looked like it was going to be a recurving storm. Then it looked like it was going to be grazing the coastline. Now, many of the models are consolidating over a solution a little bit further west. But really, there's no organized center. It's just a tropical wave right now, and that's why these models, you just have to look at them as a little bit of information. And this is the official National Hurricane Center track showing an approach to southern Florida by as early as Saturday morning. So we would likely have to fly to get into position on Friday to intercept this if it did rapidly intensify. But you can already see here that this tropical storm goes right over the heart of Hispaniola, the higher terrain too of central and eastern Cuba as well. But it is very possible that there could be a much further south track as well. This is the official latest track from the National Hurricane Center. I could even see the center being a little bit more like this, which already you're off by quite a bit. But this track is definitely hostile for any tropical cyclone coming directly over these mountains of Hispaniola. Those are like 8,000 or 9,000 foot mountains right there. They could just tear any vortex to shreds. And so that's why we just got to keep on watching this. Tropical storm watches issued for portions of the southeastern Bahamas. Tropical storm warnings southeast of there. Also tropical storm warnings on the east side of the Dominican Republic and including Puerto Rico. Definitely tropical storm conditions expected in the tropical storm warning areas. Water spouts passing by in the outer bands, certainly a possibility as well. Gusty winds. But really what I'm watching is if this thing does form a little bit further south and enters into the eastern Gulf of Mexico, then it could be a much stronger tropical cyclone on approach to the southeastern U.S. Also, if this emerges from Hispaniola and stays over these very warm waters to the north of Cuba, to the south of the Bahamas, that would be a favorable track also for intensification. But really, we just need to watch this thing. And here's the latest hurricane reconnaissance flight. This is from the Tropical Tidbits website. And you can see that most of the blue wind speeds are between 30 and 34 knots. And really what you're looking for here for a closed rotation, you can see that there's a lot of easterlies, a lot of northeasterlies and southerlies here on the southern end of the wave. Overall convergence. You can see that there is an open wave with this tropical wave here, basically the winds. This is on the east side of the wave where you get more southerlies. You get more northeasterlies on the west side of the wave. And that's really what you're sampling here is an open tropical wave, a large tropical wave. There's the Hurricane Hanna aircraft. And in order to name a tropical depression, you really need westerly winds at some point during this flight path. And then you can really start to consolidate a center. where to the north of it you'll have easterlies, to the south of it you'll have westerlies. And that's what you're looking at to name a tropical depression, and that's why this has been kept potential tropical cyclone. But because it's a potential tropical cyclone, the NHC can issue cones, forecast cones for it, and it is taking it off in the general direction of southern Florida. But right now it has yet to be named a tropical depression. Once it does finally form a center, that's when the forecast models will really start to hone in on a solution. I suspect that the center is probably going to form somewhere in the vicinity of these blobs of convection. There's a lot of latent heat release happening out here, a lot of surface pressure falls, and as those positive feedbacks continue to happen, eventually they're going to be sufficient to form a closed circulation, and then a tropical depression will be named. Here are the hurricane model intensity forecasts, a little bit higher up, but still, because of the impacts of terrain, mainly topography, that is why you're seeing a conservative hurricane or tropical cyclone intensity forecast, really keeping this thing below hurricane strength during the entire time all the way up to the U.S. But these you also have to view with a grain of salt. There's not even a closed circulation yet, not even a tropical depression named, and I think that if this can avoid the mountainous terrain of the Greater Antilles and somehow enter the eastern Gulf of Mexico, you'll start to see these intensity forecasts begin to respond to that new solution. But really, we're at a waiting game right now with this system, and I would say that, So I wanted to show you the CMC, because I think it actually has the best grasp of reality of any of these models. And you can see that it's got quite a bit of chaos. I think that it has the most accurate representation of reality because there's not yet a center that's formed. So this shows the many different scenarios that could result from this large tropical wave because we just don't know where the center is going to form. This one, if it does recurve, would probably be if a center consolidated further north relative to that tropical wave. This a little bit further south of a solution could take it into the eastern Gulf of Mexico. This would be the worst case scenario right here for the U.S., I would say, because the tropical cyclone would avoid the higher mountainous terrain of the Greater Antilles and Cuba, and then enter the eastern Gulf of Mexico, where it likely would be an absolute prime scenario for intensification and even rapid intensification. It is possible that a center could form a little bit further north, and that could miss the Greater Antilles just to the north. That would be more likely a recurve scenario. Still possibly could have impacts though across the eastern seaboard. So really I think the CMC model more accurately reflects the uncertainty in the forecast downstream for potential tropical cyclone 9. It's because it's such a large wave, open tropical wave. We don't have a closed center that has yet to form. So really anywhere from the central Gulf of Mexico all the way around Florida and up the east coast and anywhere across the Greater Antilles, Puerto Rico, Haiti, Dominican Republic, and Cuba, even Jamaica, you definitely got to keep an eye on this thing. Just too much uncertainty right now to make a call. So that's really what we're looking at. Here's this large tropical wave. A zoom in on the southernmost blob. Here's a look at the overall view of the Atlantic, and you can see yet another very strong tropical wave with a mid-level circulation that's to the south of the Cape Verde Islands. That is the next one that we're watching, well to the east of potential tropical cyclone 9. But look at this conveyor belt of waves just churning off the African coastline there, going all the way across the Atlantic, and it's only the end of July. So if this is a sign of things to come, I do think it's going to be a very active Atlantic hurricane season, which means it's going to be active for the U.S. We've already had a hurricane landfall in Hurricane Hanna with 90-mile-an-hour sustained winds, minimum pressure about 972 millibars, and that's likely just the beginning of this very long hurricane season. So we're going to keep on watching this, continue these tropical updates. We're also going to watch the development of a fall season and high plains during the midsummer. We're still going to be focused on tornadoes as well. But thank you everybody for your support on here. It's making possible all of these research projects from Team Dominator, in addition to storm chasing, live streaming, and I'm going to continue these live briefings as close to every day as possible to break down the uncertainty here in the tropics, but a very active Atlantic season appears to be well underway. So thank you everybody. I hope you guys have a good rest of your Wednesday, and I'll be live again back tomorrow morning. I've got the laptop fired up as good as new. I've got a new haircut. Went to Sports Clips and got the MVP. So feeling like a new person again. Slept 28 hours over the last 2 days. So the mitochondria are recharged, and I look forward to breaking down Potential Tropical Cyclone 9, and possibly by tomorrow morning we'll have a tropical depression formed, but no guarantees on that. And we'll just keep breaking it down, and I'll let you guys know my plan and the science mission that you're supporting. So have a great rest of your Wednesday, and never stop chasing.